I'd like to introduce our next speaker. We have Dr. John Gilley. He's a research agriculture engineer with USDA Agricultural Research Service, and he's an adjunct professor of biological system engineering at the University of Nebraska-Lincoln. His research interest includes manure management, a thing close, near, and dear to my heart, surface hydrology, water quality, and soil and water conservation engineering. Dr. Gilley's current focus is on identifying cropping and management practices for utilizing manure as a nutrient source and the soil amendment without causing adverse environmental impacts. Dr. Gilley?
There are several factors that affect soil erosion, and there's 4 of those that are listed here. Those include texture, organic matter, structure, and permeability. There are other factors, but what I'd like to do is focus on one of those factors this morning, and that being organic matter. What I'd like to do is evaluate a case study of an exarban soil. Exarban soil is a state soil here in Nebraska, and exarban is actually Nebraska spelled backwards. I know there's lots of Husker fans out there, and so if you would just for a second, just imagine this site planted to corn and Herbie Husker running across that cornfield. During this past summer, we collected soil samples at a site east of Lincoln at the Rogers Memorial Farm, and this shows some soil sampling being collected at the site. So what I'll do next is share some of the results of the soil and vegetative analysis that we collected. Looking at organic matter, we see that the organic matter at this site varied from 3.72 to 2.7%, and this is at depths from 0 to 10 to 20 to 30 centimeters. The bulk density for this site also varied from 1.44 to 1.63 grams per cubic centimeter. So what we do is go through and do a calculation and find out what the total organic matter was in this soil in the 0 to 30 centimeter depth, and we find that organic matter was 147 megagrams per hectare. So if you would, please just keep that number in mind. Looked like there was quite a bit of residue out there on this no-till site, and there definitely was, and it turned out to be 7.73 megagrams per hectare. Not all of this 7.73 is going to be directly transferred to organic matter, but that at least gives you a number to tell you what a potential source of organic matter might be. There are things that you can do to increase organic matter. One of them is to apply manure. This shows you the amount of beef cattle manure that's required to meet the nitrogen needs of a corn crop going in this area. See, there's quite a bit of beef cattle manure that's required there. And this shows you also what the amount of swine slurry that's needed to also meet the nitrogen requirements for corn. So when you go, what I'd like to do now is present some of the results from the laboratory analysis of these materials. The dry matter for the beef cattle manure was 56.4%, so it was relatively wet. It was taken just from a feedlot soon after the area was cleaned, and the amount of dry matter of the applied beef cattle manure was 26 megagrams per hectare. Looking at the dry matter for the swine slurry, that was 5.35%. It's really liquid, and the dry matter for the applied slurry was just under 2 megagrams per hectare. So what you want to do is to compare this 26 megagrams per hectare and 2 megagrams per hectare to 147 for the organic matter. And the take-home message from these quick calculations are that soil organic matter is something that is very difficult to change. It's something that takes quite a bit of time. And the second take-home message is that if you're working with a slurry material like swine slurry, there's not much chance that there's enough dry matter actually there to significantly impact the organic matter content. So what I'd like to do now is sort of switch gears and present the results from a study conducted by my colleague and friend, Mark Reese at the University of Georgia. And it was a study to measure runoff and soil loss as affected by the application of manure. The report was published in 2000. And I'll wait just for a second here so people can write down the reference if they'd like to refer to it a little bit later. So what I have shown here is a picture of the first Soil Conservation Service chief, Hugh Bennett, and this is at one of the research stations established during the 1930s. This particular station was in Guthrie, Oklahoma. You can see a series of runoff plots located there. And so what Mark and I did was go back and collect some of this historic data and then use it for some of our calculations. Next, we have a picture of some technicians servicing erosion plots in Missouri in the 1950s. When you collect runoff data, natural runoff data from field plots, is something that's obviously very labor intensive. It's something that's very expensive, and so therefore there's really not a lot of that information available. Hugh Bennett established 10 experiment stations in the 1930s. The plots were 6 feet wide by 72.6 feet long, and they encompassed 0.1 acres. Some of the research which they examined there included factors that affected erosion, including slope steepness, slope length, type of crop rotations, and conservation practices. And one of the variables that was examined on some of these sites was the effectiveness of manure in reducing runoff and soil loss at that particular location. The sites where manure was applied included research locations in Missouri, Iowa, Wisconsin, New Jersey, Minnesota, Idaho, and Pennsylvania. So what Mark and I did was go to this historic database, look at the data that was collected, and then summarize the information. And we found that manure application at these sites reduced erosion from 2 to 62%. Manure application reduced soil loss from 15 to 65%. And we also were able to develop some regression equations that related runoff and soil loss to manure application rates. What we have here on the y-axis is a runoff ratio. If you had no effect, if manure application had no effect on runoff, then your value here would be 1. All of our values here are less than 1, which tells us that the application of manure helped reduce the amount of runoff that occurred. And from the values for the various sites, we were able to develop this regression equation. We were also able to develop a similar regression equation looking at soil loss ratio as a function of manure application rate. And again, we see that as you increase the manure application rate, you're going to increase the erosion reduction effectiveness caused by the manure. Now, this information was collected in the 30s and 40s. Obviously, our cropping systems and our management systems now are much different. So it is something that we recommend that people go out and actually use these exact numbers, but these regression equations and this information presented in the paper should give you a relative idea of the effects of manure application on runoff and soil loss. So I thank you very much for your attention.